Hello friends, welcome to a fresh new episode of our channel RG Innovations. If you have not subscribed already, please subscribe to our channel, click on the bell button and select all to get all future notifications of our video uploads. In my previous videos, I have discussed about what is a NOR gate and I have shown a 2-input and a 3-input NOR gate and its demo. In this video, I am going to discuss why is NOR gate called an universal gate. The NOR gate can be said to be universal gate since combination of them can be used to accomplish any of the basic operations and can thus produce a NOT gate, an OR gate or an AND gate. The non-inverting gates do not have this versatility since they cannot produce an invert. NOR gates are called universal gates primarily because they are available universally. They can be combined to produce OR, AND and NOT gates. They are widely used in the integrated circuit package and they are easiest to manufacture. In simple words, a combination of NOR gates can easily be combined into a NOT gate, an OR gate or an AND gate. And in this video, we are going to practically learn how to do that. How to convert a NOR gate to a NOT gate. This is simply made by joining the inputs of a NOR gate. As a NOR gate is equivalent to an OR gate leading to NOT gate, joining the inputs makes the output of the OR part of the NOR gate the same as the input, eliminating it from consideration and leaving only the NOT part. We can see in the diagram, this is the desired NOT gate where A is input, Q is output and Q equal to NOT A. By a NOR gate, we can construct it like this. Simply joining the two inputs, this will give an inversion of the A in the output Q. If we look at the truth table, if input is 0, output will be 1 and if input is 1, output will be 0. Now we will implement this using an IC 74LS02 or 7402 IC. We have shown this IC in the 2-input NOR gate demo. So we are not going to much detail about the IC. I'll give the link in the description, you can check. We are going directly into the circuit. So this will be the circuit where we are using this 74HC02 IC. We have connected its two input and giving input to this via this switch, and we have connected an LED to the switch so the status of the input can be displayed. When the input is high, this LED will glow, and when the input is low, this LED will not glow, and the output is given to another LED to display the output status. Whether the output is high, this LED will glow, and when the output is low, this LED will not glow. This resistance is used to limit the current to this LED. And we have used a pull down resistor here so that the output does not fluctuate when there is no input, and another resistance is used here to limit the current to the output LED. So the circuit is very simple. Now we will see a live demo of this. So here is the circuit that we have built using a 7402 IC. The input 2, 3 is interconnected and the output is connected to the output LED, and this LED is connected via a current limiting resistance, and the input is grounded using a pull down resistance. This switch will provide the input to these two pins and this LED will show the input status. Now we are giving the 5V power supply to this circuit. This is the positive power supply and this is the negative power supply. You see, as soon as we connected the power supply, the output LED started glowing. It is because now it is working as a NOT gate. When the input is low, the output is high. And when we'll press this switch, the input will be high and the output will be low instantly. Again, when the input low, output high, and input high, output is low. So this satisfies the truth table of a NOT gate, and we have successfully built a NOT gate using this NOR gate IC. So after this, we will see how to convert a NOR gate to an OR gate. An OR gate is made simply by inverting the output of a NOR gate. Note that we already know that NOT gate is equivalent to a NOR gate with its input joined. So our desired OR gate is like this, where A and B are inputs and Q is the output. So Q equal to A or B, and the NOR construction will be like this. One NOR gate. So if A and B are input, so here it will be A NOR B, and then this output will be inverted to produce A or B. So if A and B are the inputs and output is Q, this will be 0, 0 equal to 0, 0, 1 equal to 1, 1, 0 equal to 1 and 1, 1 equal to 1. We will implement this also using the 7402 IC. Since the 7402 is a quad 2-input NOR gate, so there are 4 NOR gates inside that IC. So we can easily cascade 2 NOR gates in that. And now let us have a look at the circuit. Here this is the same IC 74HC02, and we are using 2 segments of NOR gates of this IC. Here we have to provide two inputs to this. So we are providing the input to pin number 2 and 3 via these two switches. And as we have discussed, we have connected these two LEDs for showing the input status. And we have joined the input pin number 5 and 6 to invert the output of first segment of NOR gate. So the output of the first segment of the NOR gate is fed into the connected two inputs of second segment of the NOR gate, and output from the second segment of NOR gate is fed to this LED. Here are two inputs, so we have used two pull down resistances. So this is the circuit. Now let us move on to the practical demo. So here is the circuit of an OR gate using a NOR gate IC 7402. We have implemented a 2-input OR gate here. So here are the two inputs, and these two are the input status indicator that is connected with this switch, and we have fed the two inputs to pin number 2 and 3 of the first NOR gate segment, and the output of first NOR gate segment pin number 1 is then sent to pin number 5 and 6. Pin number 5 and 6 interconnected using a jumper loop, and output from the segment 2 NOR gate pin number 4 is then connected to the output status LED. And now, as we are providing two inputs to two different pins, we have used two separate pull down resistances in this circuit. Now we will give the power supply and check it. So we are providing 5-volt power supply. This is the positive power supply. This is the negative power supply. Both the input switches are in off position now. So here is no input, no output. Now we will match it with the truth table of an OR gate. So 0, 0 is output 0, 0, 1 is output 1, 1, 0 is output 1, 1, 1 is output 1. So this circuit satisfies the truth table of a 2-input OR gate, and thus we have successfully built a 2-input OR gate using two NOR gates. If both the inputs low, then output is low, and if any of the inputs are high, then output is high. Now, after seeing the practical demo of the OR gate, we will now implement the AND gate using a NOR gate. An AND gate gives one output when both inputs are 1. Otherwise, when any of the inputs are 0 or all the inputs are 0, the output will be 0. Therefore, an AND gate is made by inverting the inputs of a NOR gate. Again, note that NOT gate is equivalent to a NOR gate with its inputs joined, as we have said earlier. So our desired gate is this AND gate where A and B are input and Q is output, where Q equal to A and B, and the NOR construction will be like this. First we will invert the inputs, input A, that will be inverted input A, and here we will invert input B, so it will be inverted input B, and the output will be A nor A nor B nor B. So the output will be A and B. If we see the truth table, it will be like input A and input B 0 0, output 0, input 0 1, output 0, input 1 0, output 0, input 1 1, output 1. We will see the practical demo of this also, but before that, let us have a look at the circuit diagram. As we have said, the 7402 IC consisting of 4 NOR gates, so we will be using 3 of the NOR gates in this circuit. So first we have connected the inputs of segment 1 NOR gate. We have connected the inputs of segment 2 NOR gate, that is pin number 5 and 6 we have connected, and pin number 2, 3 we have connected, and we are giving input to these two pins by switch A and switch B. Like the previous schematic, these two LEDs will also show the input status, and this LED will show the output status, which is taken from the third segment of the NOR gate. And we have fed the output from segment 1 and segment 2 outputs to the inputs of the segment 3 of NOR gate. As per the circuit, we have given the input to this, and this output is taken to this output status LED. Now we are moving on to the practical demo of this. And here we have built the circuit diagram of an AND gate using a NOR gate, the same IC 7402. And here we have used 3 segments of the NOR gate. We have interconnected the inputs of 2 segments. Segment 1, pin number 2, 3, we have joined using a jumper loop here. And pin number 5, 6, we have interconnected using a jumper loop here. We have given input to pin number 2, 3. One input to pin number 2, 3 and another input to pin number 5, 6. And output of segment 1 from pin number 1 is connected to pin number 9, and output pin number 4 from segment 2 is connected to pin number 8. And the output from segment 3, pin number 10, is then connected to the output status LED, and rest of the circuit is same. Two pull down resistances used in two segments, and one current limiting resistance to the output LED and one current limiting resistance to input LEDs. Now we will connect the power supply 5 volt and test. This is the negative power supply and this is the positive power supply. This digital ICs works in 5 volt, so do not give more than 5 volt, the ICs may burn. Now we have provided the power supply. Since both the inputs are low, the output is also low. Now we will match it with the truth table of a 2 input AND gate. So 0 0 is 0, 0 1 is 0, 1 0 is 0, 1 1 is 1. So you can see only when both the inputs are high, the output is high. Otherwise, in all cases, the output is low. Whether two inputs are 0, output is 0. Whether any single input is 0, output is 0. So this satisfies the truth table of a 2 input AND gate. So now we have seen how we can convert a NOR gate to NOT gate, OR gate and AND gate. So that was the practical demo of a NOR gate as a universal gate and converting NOR gate to the other basic gates. If you have any confusion, please feel free to ask in the comments. So today up to this, in our next video, we will start with NAND gate. If you like our video, please press the like button, and if you have not already subscribed to our channel, please subscribe and share it with your friends. We will meet again in our next video. Till then, bye bye, take care, have a nice time. Thank you.